All right. Thank you. Welcome, everyone. How you doing? Yeah, great. I am stressed out. Anyway, uh, well, let's get started with this clean code journey. Um, First of all, thanks for being here. I'm Ernesto, one of the organizers of this conference, and I am also a software engineer at YouGov. Uh, Obviously, I'm passionate about computer science, cooking, and food. So you can just spot this because I'm Italian, so this can be pretty obvious, right? So why this talk? This talk, the inclination is because when I started, I wrote back code. So when nobody cared about reading the code, testing the code, basically having an actual code, I decided to change my job. Changing my job and started learning the motivation behind the cleaning of the code. And so I think, like so many others, I stepped into Uncle Bob. This helped me a lot. So what is clean code? By some definition, I think clean code on the internet, I read some stuff, and I came with these four main points. It should be readable, maintainable, elegant, and testable. And as a consequence, all the things probably make it hard for bugs to hide. Well, I think there is no a single definition that states what a clean code is. But I'd like to show you two sentences. I think they are very representative for this topic. The first one is from is one of the inventor of UML. It says that clean a code that reads like a well-written prose. I think this sentence is like the rule of the thumb because if you think at some code, so you're reading at code, you're reading at the whole code basis or some portion of the code. If you don't go back and forth to understand what's going on under the hood, I think that that code has all the rules for being a good code. Clean code always looks like it was written by someone who cares. I think that when you write code, you have to care for the next developer afterwards. Because if you care and then you care for who will read the code after you, you should write code that is clean and readable enough for all the other contributions that will read your code base. Now I'll try to give you my point of view. This is Leonardo DiCaprio in Spaghetti Code meme, but uh, how the code is written, I think matter a lot. Because when you're new in a project, you don't know anything about the context. You don't know anything about what's going on in there because you're new in the team. So when you read the code for the first time, you rely on it. You have to rely on it mandatory because you knew. You don't know anything about that code. So it has to be readable. You have to read it and you have to understand it the first time you read it. Well, I've seen some clean code definition, right? We went through some definition. Uh, so the first question is, how can we measure it? Is there any possibility to use a metric for calculate the cleaning of the code? Do you know that? I think when I show you the next slide, I think you have seen the picture. So clean code measurement is defined. We have to calculate what the fucks per minute, okay? So if we calculate what the WTFs per minute, it's the right metrics for calculating clean code. Well, I've been in both sides of that door actually. So the delivery, so the takeaway of this talk, I hope that will be how to reduce the what the fucks per minute. And these are not all the rules that are underneath the clean code because it's impossible to shrink all the rules in 25 minutes. So I'll try to mention some basic concept as a starting point. So first of all, let's talk about reading and writing the code. When we read the code, I think we spend 80% of the time, and when we write the code, we spend the 20% of the time. So when you start a greenfield project and you start coding, your productivity can grow and you can just add feature on top of feature on top of features. But at some point, if you realize that the code portion needs a refactoring and you avoid the refactoring for laziness or, lack of time or whatever, you're committing a crime. You're committing a real crime because at some point, when you do not do the refactor, your productivity will be asymptotically to zero in a few time. Moreover, if you think this from a company perspective, so this is, these are all my opinions, right? Okay, so we can discuss it later. But from the company perspective, this is not affordable. Even if you put more coders, developers on top of the code base, on top of the team, this is barely impossible to maintain and mess your sloppy code. What prevents clean code though? So if you say, okay, if your mindset is, I'll do the refactoring later, but later never comes, trust me, never comes. So if you start avoiding the refactoring, so maintaining sloppy code, you will have sloppy code, and that's it. Please don't be in this mindset. And this is what states the Boy Scout rules. Do you know what is the Boy Scout rules? No? We'll see it later. I don't want to spoiler you this interesting slide I have at the end of the presentation. Well, so is it worth it? Owning a mess, is it worth? Basically, if you take a look at this ugly function, in my opinion, this is ugly, it's not readable. We can see that refactoring the code in 3 separate functions, organize the caller to have a clean sequence of invocation can be worth or not, because I think a function like this versus 3 functions, it's better for the simple reason that it's more readable. We can then redefine the caller calling the first one or I don't know, whatever. But it also means that 3 small objects, functions, or methods like these are even testable in isolation. So let's see some basic but important rules for writing clean code, starting from the basics. We start from names, okay? Use descriptive names. Don't be scared about having long names. Nowadays we have autocompletes, right? We all use IDEs or stuff. So in a few words, the name should represent the developer's idea, always. And in the code here, the D is, what is D? Why we have to use D or DA? What the fuck, right? So this, since creation can be more interesting as a name, more descriptive. Use meaningful names. Look at that variable, moddymd, what the fuck, right? Variable in general should have meaningful names. When we read them for the first time, we have to understand the intent of the developer. Here, the developer is basically assigned to that what the fuck variable here a datetime. Why we have to specify that capitalize Y in there? We can spot that we have year from the value, right? So it's not mandatory to have the Y there. So it can be confusional for who comes after you. And then modification date can be a better name. We don't have to specify the Y there. Why we have to specify and that's why I always mention what the fuck, yeah? So name should be searchable. We should avoid using single char variables, abbreviation like sum, temp, flag. This can be maybe in the something that is used in third-party libraries. So when we find them, they are not search-friendly names. We should use search-friendly names and avoid common words like the one I mentioned. Important thing, class names. Class names should be noun or noun phrases like, customer, wiki page, account, or whatever. So a class name should not be a verb. It can be misleading, I think, unless method names should have a verb or verb phrases names. And more importantly, they should say what they do. if you take a look at the example, we are applying a method called add at the object date. But what are we adding? 5 years, 5 months, 5 days? We don't know that. Just add the suffix at that function called add, and we can be more expressive about what's going on in there. Well, looking beyond the object name, we can also see how code can be bad if we use comments in the wrong way. Remember, comments can lie. Okay? So they lie, they can have all comments and describe something that the code doesn't do anymore, because the developers can change things time after time, but they don't do the refactor of the comments because they are lazy. And then we have, during the code review, we'll have a lot of WTFs. Code never lies. If comment lies, code never lies. If you take a look at the first snippet here, we are relying on the billing repository in the return statement. But the comment says that we are returning something from the stock repository. That is a lie, because maybe the developer changed the return statement, but he forgot, because he's lazy, to change the comment. So reading the code after you is going to be fucked up, because it can say, okay, what's going on in there? We are returning the billing repository, but the comment says another thing. It can be confusional, right? So on the second one, there is a lie as well, because we are stating that if it's not none, but it not true, this is not true, because we are relying on the greater than 0. But I think that that comment is absolutely unnecessary, because the code explains itself very well. Look at the code. If element is greater than 0, return the square root of the element. Why we need a comment there? I mean, comments should be meaningful for something that is real complex. But I mean, this is also can be a discussion, because if you write something complex, it means that maybe there is something going on that you can refactor as well. But this off topic, okay? Other than that, I think comment can be lazy. Comment can be lazy because they attempt to, writing a code like that one, we are saying that calculate side length using a Pythagorean theorem, whatever, and then we are using delta H, R1, R2, whatever. It's basically, the developer here was describing with the comment something hard to understand, instead of refactoring it and get rid of the meaningless comment. That function, for example, that portion of code can be something like this, getting rid of the comment, because using proper name for variables, using chaining of square root or whatever, we are just, it's not worth it to have that comment anymore, right? So using a comment to avoid programming effort is a crime, in my opinion. Well, so instead of using comment for explain bad code, you should make it better. And I think it's very important. And now let's see other interesting rules. When you write a function or a method, your function or your method should be only one thing, okay? For example, here we have this function that returns two entity of two instances, different instances of for example, a Django query using the OR Django. And a better solution can be splitting that function into two separate functions with one return statement with one instance, and maybe organize the caller better. And more important is that retrieve flight info is not a good name, because if you remember, I said that the function should do only one thing, and they can explain what they are doing. Okay, information is misleading. What is the information? It can be flight, it can be passenger, it can be tickets, it can be whatever. Using a proper name for function like retry flight, you know that, I mean, you might know that at the end of the function, you're returning the flights, right? So even more, if your function does only one thing, and if you follow this rule, it is guaranteed that they will be small and testable in isolation, more important. So how we can define, or better, how we can check if the function is doing only one thing. This concept has been explained very well by Uncle Bob in one of his talks. Basically, he says that you start extract a part of the original function in another function. If you can find a way to extract, that means it should be a different function, okay? Once you cannot extract anything from there anymore, you should be sure, you can be almost sure that the function, the method, is doing only one thing. If you look at the code, we can extract that things from there. I mean, just look at the number of the lines. You don't need to read the function. It's just basically 100% that you can extract something from there. So we can, I mean, start extracting. We can find out three separate functions. They can be testable in isolation. So we can start writing unit tests for there, not all integration tests. And for that, I mean, keeping things small means also that we have to reduce the cognitive and cyclomatic complexity. Cyclomatic complexity determines how difficult your code will be to test. Cognitive tells you how difficult your code will be to read and to understand. We have tools for that. For example, Flake8 tells you with some warning that your code is too complex. So maybe there is, it's smelling, your code is smelly. If Flake8 is that, probably it's smelling. So I think that a complexity like this, that I can count like 6 as a cyclomatic complexity here, can be divided into 2 functions with 1 as a complexity each function, like this way. I mean, they are just example. They can spot some typos, I guess. Alessia, I don't know if you found some spots here, but it's just examples, right? But another rule I found very important is that sometimes you can apply the low-ordered meter, or better known as the rule of 1 dot. In particular, it states that an object should avoid invoking methods of an object returned by another method, like, I know, a book.pages method.latest last method.text method. It's basically chaining all this stuff. It's gonna be hard to read in a while. So, for example, think about this analogy when you want a dog to walk. You don't command the dog's leg to walk. You command the dog to start walking, right? So in the first example here, we are just iterating over the legs and tell, okay, leg 1 move, leg 2 move, leg 3 move. You can just do dog.move and increase the complexity of the dog itself without knowing any internal of the dog, right? So this is very interesting. I found this example in this very interesting article in the IEEE journal over there. The advantage of this thing is that following the law of the Demeter is that the resulting software tends to be more maintainable and adaptable. We can, okay, increase the complexity of the object, but we can decrease the complexity of the callers and of the public APIs. And more important, we can just avoid tight coupling as well. Well, what are the drawbacks? The drawbacks are that we cannot apply this rule to cats because, I mean, this is an ethic thing, right? The most obvious thing I told you is just increasing the complexity, and we have to try the compromises. Another aspect I would like to focus on is that we should avoid premature optimization. Premature optimization means that spending a lot of time on something that you may not actually need. What does it mean? Basically, I will go with an example. A startup that spends an enormous amount of time trying to figure out how to scale the architecture to, I don't know, handle 1 million of users, unless they should start validating first the user feedback, maybe start scaling on 100 of users because they have 10 users today, right? So why we have to introduce functions or introduce complexity today when we can do it in the future? This can make the code unclear, because if we start, paying a new developer from tomorrow, and he or she sees something huge, it can be complicated to introduce the coders in something that is huge when it's not needed, because they can be all the features can be misleading by someone new. And furthermore, another thing is that I found very interesting is this continuous refactoring, that is the segue of the rule of the Boy Scout. That basically it states that you must leave the playground cleaner than you found it. So when you are a developer, you are going through a code, so you think that code is bad, or it can be written in a better way, you should do that. So you have to clean the playground that someone left before you. So you are sure that doing the continuous refactoring is basically something that, in my opinion, can reduce technical debt. And also, basically, the company today should do this approach to reduce the efforts for maintaining the code after 2 years or after 5 years. The rules, okay. Obviously, all the rules I gave you for having a clean code, and especially when we do refactoring, cannot be applied at all if we don't have tests. If we don't have tests, how can we be sure that changing some code, refactoring some code continuously, and we are sure that all the things are still working? Without tests, it's basically impossible, right? So tests are mandatory, and they can, we can rely on tests, we can rely on code bases, but we cannot rely on these things separately. They have to be strongly connected. So going back to the caring concept, you have to care, right? So if you care, you need to write tests, because you are caring for your next colleague, your next developer on your code base. So if you care about who is reading the code after you, you have to be precise when you code. Also, experience matters. So when you ask yourself if the code is clean enough, is readable enough, it has tests or not, you should check if your code smells. And I just listed something that I found very interesting. Just some concept that I think that is related to code smelling. Well, what I've covered today are basically 5% of the topics underneath the clean code. And I think each slide of this one, as Patrick told me a couple of days ago, can be a talk itself. But I think that because, I cannot tell you anything else, because unfortunately we are out of time. So thank you so much.
Thank you, Ernesto. There are some questions.
Fuck.
So, the first one, do you actually test in production like your shirt say?
All the days. Alessandro?
Next one, are linters enough to enforce clean code?
Sorry?
Linters enough to enforce clean code?
All the things that we can use for spotting something that, linters or formatter or whatever we use can be very important. Like also, linters are useful, but we can use a lot of stuff in our tools, in our continuous integration or whatever that can can spot things for us. So it's just like an iteration over and over the code. I think it's yes. The actual answer is yes.
Okay. So, if I have the same code written 2 times, do you think it's better to be dry? It's is necessary and sufficient condition?
To be?
Dry. Don't repeat your.
Oh, yeah, of course. Uh, I mean, if you have two things that is doing, I mean, if you do two things repeated over and over in your code base, it can be a smell. I mean, if you think that that is a smell, so rewriting it and then you have a couple of things, it's a good reason to be dry.
Next one. Any recommendation how to enforce clean code?
How to enforce? Wow, that's a very good question. Enforce clean code. Uh, Nazism. I'm kidding. Sorry. So basically, sometimes when I do enforce clean code, I think one of the most important thing to enforce clean code is doing multiple code reviews. When you have a pull request and you ask a code review to only one person, it can be biased because for example, when I do a code review, I spend a lot of time because it's going through GitHub and reading at the differences. I think it's not enough to spot something that smells. I mean, a test that is missing something or whatever. So I think that having multiple code reviews and not only async code reviews, but synced code reviews like meeting face to face, or I don't know, as a remotee, I can see, okay, let's do a meeting over Zoom or whatever, and let's do a code review like a pair programming session. It can be very worth it to spot smells and so improve the clean code of your code base, the clean code, shape of your code base.
Thank you. An interesting one. What do you believe or hope becomes possible if everyone wrote clean code?
A better word.
Next one is what about design pattern abuse? Can you elaborate why that's a code smell?
Because I mean, we have a lot of design patterns, right? So when you design a software and then you go with the design pattern, and then at some point you decide that the design pattern is not good anymore because the specification or the customer needs is changed, uh, you have to change the design pattern and you have to do it in time. Otherwise, if you go with the design pattern and then you go adding feature on top of feature on top of feature on top of on top of features, at some point you have to spend 1 year to change the design pattern, and this is not affordable. That's the reason why I think that the relying on design patterns sometimes can smell on the code. But this is my opinion. Maybe we can discuss each other outside.
But okay, not now. Okay, we have time for the last one. In open source, small pull requests are preferred. Should I propose refactors in standalone pull request?
Mm, is the author of the question in this room? Can you elaborate a little bit more, please? Nope, at all.
It was actually a trick question because I'm the guy who like reviews PRs, and
How lucky are you?
yeah. So the question was, usually in open source, we prefer like small pull requests, so they're easier to review. but when I write changes, I usually see unclean code or code smells near the parts I'm changing. So the question is, should I change them as well and sneak them in my PR, or should I propose those changes in a separate PR? So
I will go with a separate PR, but it's basically what we do in my company, and I found it very useful. But I think there is no rule. I mean, having a small PR for introducing a feature, if you think that feature, I mean, it depends also on priorities. Sometimes customer needs some bug fixes or whatever in uh, 1 hour if we do continuous deployment or stuff like that. So if you think that that code is well enough for today, okay, you can deploy it, you can deliver it, but in the same time you click the delivery button or your continuous systems does that for you. At the same time, we should create another ticket, another story in which system you use in your company that automatically says, okay, we have deployed it because of that, but this has to be refactored in another ticket, in another PR for this other reason. This should be like a segue if you do that because of a need of a customer. Because I know that sometimes having clean code can be a waste of time, but sometimes it can be managed I mean, we have to find compromises. So at some point, I don't have the right answer for that, but you have to, I mean, follow your art.
Okay, we have finished the time for question, and before to go for lunch, very important things to do is to take a selfie with also Ernesto. Say hi. Thank you. A big applause.
Thank you, everyone.